All right, good morning, everyone. Thank you for getting through the rain, coming to this early session. I really appreciate it. There's a huge amount of interest in Postgres in the industry. It's really never been a better time to migrate. Of course, the migration of apps and data between incompatible database services, it can be a hard problem to solve. So it's potentially a really excellent use case for AI. So that's the topic. We do have a lot to cover, so let's get going, and I'll start with some introductions. So I'm Guy. I'm the product manager for Azure Database for Postgres, also known as Flexible Server. With me today, I have Jonathon. He's the PM lead for AI migration tooling. And I'm very happy to welcome two guests to this session. So we've got Luigi, who's the CEO of DBtune, and we've got Ashokkan, who's a Chief Information Officer for the Hospitals Division of Apollo Hospitals. So what are the four of us going to be talking about today? I'll divide it into four parts. And really, part one, I'm going to do just a bit of level setting of why Postgres, why Azure Database for Postgres. I'm going to do this really quickly because we've got some really good content. Ashokkan is going to take us through his story, a very large Oracle migration to Azure Database for Postgres for Apollo Hospitals. And then Jonathon is going to take us through some brand new AI-assisted migration tooling. And then Luigi is going to share a new offering from DBtune on the Azure Marketplace for performance optimization post-migration. So I'll get started. Why Postgres? Why on Azure? Another way to say that might be, why did we all get up early and come here today? So let's do a very, very quick level set. You've probably seen a version of this before. Postgres keeps extending its lead in terms of the most popular database for professional developers. Everyone has their own reasons for that. I'll maybe pick three. One, it's one of those rare cases where old is actually good in the software industry. It's a very highly optimized and stable query engine that's been refined over decades. Another big one is the extensible design. You can solve pretty much any problem with an extension. So you've got a geospatial problem, install PostGIS. You want to work with AI, install Vector. So this way, this really mature database service stays at the cutting edge. And there are hundreds of extensions you can use. Another really important factor is that it's open source. It's independent. So there's no license fees, which means you're only really paying for the infrastructure that you're running it on. Now, ultimately, once your technical needs are met, then costs ends up becoming the deciding factor. So I think this is really why there's this acceleration of interest in migration. But why managed Postgres? You can run Postgres on your own VMs. A lot of us have it running on our laptops, and you can just pay for the infra. So why use PaaS? And it's really about the things you need to do to run a production service. There is a lot to take care of, which takes time and money. So, for example, if you have a security issue, you could be in the news the next day. It's extremely costly to get anything wrong. If you have compliance requirements, again, a huge amount of work and complexity needs to go into doing that correctly. Then there's high availability. There's scaling to workloads. There's performance tuning. There's a whole load of things you need to get right for a production service, and that's where the return on investment comes in. And you can measure it, and you get a better return if all of these are being taken care of. But it's a commitment from us as well to get this right. Here's a kind of a small sample of household names that are running Azure Database for Postgres. There are many more. They're willing to bet their production workloads on managed Postgres. And it's because we've been building the kind of enterprise features that they need, and they've been asking us. And so it is a responsibility from us to our customers, although we also have a responsibility to the open source community as well. Microsoft is the largest hyperscale contributor to open source Postgres. So for Postgres 17, Postgres 18. So we take this responsibility very seriously. And this benefits everyone using Postgres. So if you look at a feature like asynchronous I/O in Postgres 18, it was developed by Microsoft contributors. We made Postgres 18 available on the day the community released it, and we're making it GA this week. And It works really well for Microsoft as well, because if a customer has a thorny issue, then we've got access to some of the best expertise in the world to go help solve that problem. So that'll kind of finish my level set there, but I did want to just leave you with one slide, which is kind of the one place that captures all of the Postgres things that we're announcing at Ignite. And you can go to this short link, ignite-25-pgsql, to read more about these. So I'll leave it there, but do come and chat at the end of this session anyway, for more information on any of this. So with that, I will hand over to Ashokkan to tell us his story about the Apollo Hospitals migration. All right, thank you.
Thank you, Guy. Good morning, everyone. My name is Ashokkan. Flew all the way from India to be here, and then happy to be here with all of you today. I'll try and then step back a context as to why we chose PostgreSQL, while Guy had a different reason as to why PostgreSQL is. I'll touch back on the vision that we started with way back in 1983 and a 4-decade-old organization, keeping the empathetic care at the center and being patient-centric and making affordable patient care possible for all of us. So that's the vision that kind of gave a way for us to decide what's going to be the health system of the future in terms of how do we think. And that kind of contributed to the fundamental foundation of how do we want to bridge our basic hospital operating software, which is a combination of the HIS and the EMR systems and the way that we operate. So a couple of challenges that we looked at when we want to compare ourselves with where we need to land are the specific set of challenges that, some which Guy alluded to. One in terms of the way the legacy backend that we had hard to maintain and scale. We were fragmented in our systems and approaches. And we wanted something that would be agile and that would be more supportive for the future vision that we laid out in the last slide. So what we chose our journey by reviewing at least 6 months of selecting what database systems that we want to do. We kind of reviewed Mongo, we kind of reviewed Cosmos, we kind of reviewed PostgreSQL. The clear 3 top objectives that helped us to move with PostgreSQL was, one, the extensibility that Guy spoke about, the PaaS offering that we had on the scalability and maintenance, the security that it offered. These are the 3 things that kind of made us focus more on the business function rather than the tech function that we need to do for our hospitals. One key factor that helped us to achieve is the performance metrics that we had and the user experience that we could do. We started our journey with a partner called Quadrant Technologies. We had a huge internal development team that kind of helped us plow it through from set of actual work that we do in terms of different models that we need to look at, either it be it data transformation between Oracle and PostgreSQL, or the re-architecturing of the applications from the on-prem hyper-converged infrastructure to a VM infrastructure on the Azure clouds, or the efficiencies and gains that we need to do in terms of how do you maintain and manage based on telemetries that you now get powered from the PaaS services. The last is the data structures that we had. Given the application that we had was about 2.5 decades old, you will have to migrate all those data sets back into cloud. So we kind of used multiple toolings and technologies for us to look at. We at least had 3 different tools that helped us to manage data migrations. QMigrator for a simple one-shot snapshot, and then you had Strim for doing bidirectional during the cutoff, and we had some custom tools to write the check and balances, etc. So from that standpoint, taking a good data migration strategy is very important for all of us. Moving on, I would want to kind of give some lessons learned that what we had from as a hospital health systems. I'm not going to go over each one of them, but I'm trying to coin them into 3 functional groups. How do you manage your capacity that you want to plow into the Azure flexible servers that you want to look at? The way the PaaS service that offers gives you fundamental boost up in terms of what you want to do. So having a higher configuration at times may not be performant for you. So leveling up with the right set of performance metrics is important. So we ran a separate instance of performance tuning and then looked at what's going to be the optimal for our business loads. The next is the master data management services that we had. We had a separate master database in the Oracle world which ran on MViews and things like that, which is more on a dynamic cache model. But with Postgres 15 as the targeted version that we had, did not have those view models that we could do. So we kind of had a logical replication setup done where these were physical tables that replicated as and when a new master data element that come in. And that kind of paved a little constraint for us to think on a large scale model, which I'll allude to in the next couple of slides. So those are something that we need to look at to say which targeted Postgres version and what the limitations around it that we need to figure out. So one of the key things that we had is the auto vacuum as a process, which kind of helped us to manage the multiple temporary tables that we used during the legacy applications. I'm sure with Oracle world, managing through temporary tables was the best way to manage performances. I think that's not in PGSQL. So we kind of learned along the way and then start doing those application re-architectures. The other ones that we want to kind of say is on the logical replications. Looking at the failover slots, looking at the stat replications will help you do those telemetry management to say, is your flexible server consuming a lot of throughputs and computes? So we kind of used Microsoft and the partners' ability to kind of bring those maintenance models back in our systems to make sure that we kind of do things the right way. To kind of summarize the learnings, I kind of want to keep these 6 pillars for us to focus on, which would help us to kind of make sure that we plan effectively and then deliver things effectively. This whole migration of a 2.5-decade application that we had, along with the data sets of the 2.5 decades, the whole project ran about 18 months for us. The 12 months of full migration and the 6 months of deployment across 10 regional instances that we had. So the key aspects of having a collaborative planning with open-mindedness as to what we want to target for and how do we do things better. This is very important for us to do. What it does, I'm not going to go over the slide in full, but basically I'm trying to say it kind of improved the experience of the end users. Gone are those days of having lower performance systems. Systems were quick for people to look at. It helped us to pave the way for innovation for the future vision that we kind of laid out. This is what it paved us as the next step for us to move. When we moved all of our foundational transactional applications on PostgreSQL on the cloud, we were able to top up one more layer of the entire Microsoft Fabric on top of it, which helped us to plow through the real-time intelligence, which helped us to do our dashboards and business outcome dashboards together. We have also moved into model trainings now, and then helped us to prepare the versions of clinical copilots and things like that to support our caregivers and doctors. That's from my end. Thank you so much, and I'll pass it on to Jonathon.
All right. Well, so now that we've talked about both the benefits of Azure Postgres, as well as gone through a migration journey and story, we're going to talk next about something we're very excited to announce here at Ignite, which is our new tooling for Oracle to Postgres migration inside of our VS Code extension. So I'll be giving a demo of that in a few moments. But before I do, I want to talk through a few points of the journey that we had on how we came to our design and our architecture and how we built it. And so the first thing is that as we were on this journey, we talked to a lot of customers, and a few themes emerged. One of the first themes was the importance of validating the conversion DDL. So the notion that it's not just a theoretical conversion, but actually that we're able to test the conversion in real time and make sure that the conversion is valid Postgres. Another key point that really connects to points that Ashokkan and Guy had talked about is that the version of Postgres is very important whenever you're doing a migration, as well as the extensions. Postgres is a very heavy extension database, and therefore the extensions that are both installed and activated can dramatically impact your conversion process and the optimization of your conversion. So that's something that we thought about and wanted to factor into our tooling. Lastly, the other point, and also Ashokkan had talked about this in his journey and his story, was the client application re-architecture. So once you do the schema conversion, you also then have to think about the client application code, your Java code, your Python, your .NET code that used to talk to Oracle, and now it needs to talk to Postgres. So we have built into our tooling capabilities for this conversion as well that I'll be giving a demo on briefly. So talking through the key components that we have in this tooling, right now we focus on these 3 areas. So our schema migration, your tables, your views, those artifacts, your database code artifacts, so your more complex, your Oracle packages, your procedures are also handled in our tooling. And lastly, as I mentioned, the application code as well. Jumping into the architecture to talk about this a little bit is that one of the key pieces that we wanted to bring in was that we discovered early on when we set out on this journey that can GitHub Copilot agent mode handle everything? And what we quickly realized is that as powerful as it is for handling enterprise scale database, Oracle Database DDL, that we quickly ran into issues of rate limiting, context window, and so what we decided to do was build it into a hybrid architecture. So we have a 2-part system where first, we built a multi-agent orchestration that takes DDL chunks, converts them, validates them, and does multiple steps in terms of validating the quality. From there, things that are flagged as possibly not being fully migrated, we then capture in what we call review tasks. And those can then be leveraged to invoke GitHub Copilot agent mode in order to build a composite prompt that has all of your context to finish that last roughly 5 or 10%. So jumping into a little more detail on this, we have a 3-agent orchestration. So we have our migration specialist, our migration critic, and our documentation agent. And the key piece here is that the migration specialist is then actively talking to the Postgres database during the conversion time in what we call a scratch database. And this is through the notion of agent function tools that are components of the overall agent orchestration. Now, in contrast to that is our application conversion. So this is a little bit different in that we are leveraging GitHub Copilot agent mode fully, but with a slight twist. And the twist here is that we are bringing in 2 very key pieces of context. The first is that during the schema conversion, we are building what we call coding notes. So we basically have our multi-agent orchestration asking the question, if there was an application that was being factored in, let's capture some notes, things like data type changes, the signature of the procedures may change perhaps. So we want to capture that. The other key piece is that because this is built into our VS Code extension, back in build we announced and have our GitHub Copilot context for Postgres that we're building on top of. So during this whole process, we're able then to leverage those tools, talk to the Postgres database that was previously converted in the schema stage, and then actually have a concrete verification of looking at the tables, the data types, and those artifacts. So that way, when we're doing things like looking at Java code that might be using an ORM, and now we have data type changes, it can actually validate it against concrete tables, and it's not just a theoretical conversion. So with that said, I'm going to jump into a demo and actually show how this thing actually works and go from there. So I'm going to switch over to, here we go. So we're in VS Code. This is a live demo. This is actually running the code that is on the marketplace today. So you can go and grab this and update your VS Code extensions. I'm going to go ahead and click Create Migration Project. And we're going to create a project. And I'm going to go ahead and I'm going to fill in my information here. This is actually hitting a live Oracle server. I have a DNS name here that just maps to an IP address that I have. All right. So we're going to do this. It's going to connect to the database. We can see multiple schemas available. We're going to choose one schema here in this case for us to convert. The next step here is we're going to choose that Postgres scratch database that we talked about. This is what we're going to use for that validation step. Then lastly, we're going to point to our OpenAI endpoint. So I'm just going to grab this real quick. I'm just going to go back to slides so I can grab my key in my endpoint, fill this in really quickly. All right, go back to demo. Here we go. So this is now added. So I'm going to use this to connect to our OpenAI endpoint. We now have a migration project created. I'm going to click Migrate to kick off the project. What's going to happen is a 2-step process. The first step is that we are going to connect to the Oracle database, and we're going to extract all the DDL. So it's a one-time connection. We bring everything down, and we bring it into files. And our philosophy has been that a migration project is basically a software project. So everything that we're creating, all the artifacts are just files that are in a folder structure that then can be put into a repo like a Git repo for source control and source management. Now that the schema migration has, the schema extraction has completed, we're starting the schema migration step. So you'll see that we have built this into 5 chunks, is what's been decided by our chunking rules engine. And what's happening now is that we're sending these chunks into that 3-agent orchestration. It's going through and it's converting it, it's validating it, and then it's actually then deploying it to that Scratch database. So right now it's on chunk 1 of 5, and you'll see here it's going through that life cycle for each of these chunks. It's converting it, it's validating it, and then it's the green little checkbox means that we're all good, and it can move on to the next chunk. So while this is going, I'm going to actually dive into the log so we can see a little more details as to what's actually going on here behind the scenes. So you'll see a couple of key aspects here. First is, like we talked about the version, we are detecting the version. This is being factored into the context. So right now we're using Postgres 16.10 in this one example. And we also have the extensions installed. So you'll notice that we have multiple extensions, including TableFunc. And I'll just quickly mention this extension because this is a great example of the reason why having context is important. In Oracle, there's a notion called Oracle pivot statement. And in Postgres, there's not a direct one-to-one mapping out of the box. But if you have the TableFunc extension, there's something called crosstab, which does give you great capabilities of a one-to-one matchup. So with TableFunc, it's basically 1 line of code. Without it, it's between 20 to 30 lines of code in order to write the same equivalent DDL conversion. So having that will be able to have that context. One aspect I can mention real quickly is you'll see this little X right here. So this happened because it's trying to convert the chunk. It's having a validation failure, but it's able to send it back to the multi-agent orchestration in order to validate that indeed it's actually going to run. And you'll see that after 2 tries, it was able to recorrect it, green checkbox, so it's able to move on to the next chunk. So we're getting close to being done here. So we're on the 4th of 5. One more point I can just actually mention really quickly is if I scroll down here, I can show one more key aspect. Here we go. So you'll see right here it says adding coding notes. So as I mentioned earlier, these are those coding notes that it's actually capturing these, and we're going to be using these in the next part of the demo, which is the application conversion. All right, so we're just about done. It was able to write the last chunk successfully. So while that's happening, I can go back to our folder structure, and I can make a couple observations I want to point out. So you'll see that we actually have 2 folder structures, Oracle and Postgres. So we actually have all the objects have been extracted and been converted and are now available. But now what we can do is we can actually go a step further. We can actually look at these objects. We can right-click, and we can say compare the file pairs. So we have Oracle on the left and Postgres on the right, so that way we can have that side-by-side file diff. Concurrently, another option that we have in order to do validation is that we can go to our database itself using our Postgres extension. And this is a capability that we've already had in the last about over a month now, where we can right-click on a database, and then we can do visualize schema. And this way, we can then use this capability to quickly see and validate that all of our tables have been migrated, that the relationships are intact, and lo and behold, looks like we're in good shape. Everything was converted, and we have our relationships. So that is how that works. Lastly is this report. So after the migration finishes, we have a report that's generated, and you can see we got 100% conversion rate, 34 objects. It was able to detect the version, the extensions, and walk through and show us all the objects that were converted. The last piece I want to talk about on schema conversion is those review tasks. So as I mentioned earlier, things that are either flagged or maybe not quite converted 100% by the GPT 4.1 model, we're able to leverage this list of tasks here, where then we can use GitHub Copilot agent mode and use a model that's even more powerful, like Claude Sonnet 4 or 4.5, that can take that and to do those last bit of fine-tuning to help with the more complex packages and other object types. So I'm going to not jump into that, but instead, with the time I have remaining, I'm going to show application migration, because that's the other key thing that I want to show really briefly. So I'm going to, let's see here, do this real quick. It's going to get my folder. right. So what I've done now is I've copied a folder of a little Java application into this application code folder, so it's accessible for context. I can click Migrate Application. I'm going to choose the folder that I just copied in. It's called Little E-commerce app. And then, but most importantly, is that now I'm actually going to choose the database that we just migrated and we just visualized. I'm going to actually point to that, so that way we have that for context. So I'm going to say Convert Application. What's going to happen now is that we're going to use a model, in this case, Claude Sonnet 4, and we built this composite prompt using what's called a language model tool in VS Code, extending the GitHub Copilot capabilities. So this actually calls this little tool here, so Oracle Client Application Code Converter. It's going to build a to-do list of multiple steps of all the things that it wants to go through. You can see here that I can click this little button to see the tasks. So it's going to analyze the structure. It's going to read the coding notes that we generated from the previous schema step. We're going to connect to the Postgres database, and then we're going to convert all the SQL queries, the data types, and artifacts, update function and procedure calls and their signatures, modify error handling, and then we're going to also build the Java project when it's done, and then generate some unit tests. The reason how we're able to generate some unit tests is that this is an example of we actually have two-way capability interaction with our friends with the GitHub Copilot application modernization extension. So by virtue of having that extension installed, we are able to detect if you're running, have a Java code, then we can actually add those little extra steps into our sequence of to-dos. If you don't have the extension, it handles it gracefully. It'll just move on and do the conversion without those steps. But we have that interaction going that direction. Concurrently, if you start with the application modernization extension and you want to then use our extension, we also have capabilities that can go back and forth as well. So this is going to run. This is going to take a few moments for this to go through. It's going to read the source code of the application. It's going to read the coding notes. It's going to connect to the database and run some queries in order to validate and have that concrete context. And so now what we're doing now is we're going through the reading more of the code in order to validate and build the context. See, it's able to find the pom.xml, which has the dependency for originally the Oracle JDBC driver, which now has to change to the Postgres driver. Now it has a complete picture of what it needs to do, so it's going to run through and work on making all those modifications. As it makes the modifications, because it's using GitHub Copilot agent mode, we can actually see the changes and see the diff, and then we can either keep or reject them. So we'll be able to do that in a few moments as it runs through. So we can actually start doing that right now. We can actually look at the pom.xml. You'll see I was able to go into here and find the Oracle JDBC driver and update that to Postgres. So that's a great first step. And now as we went a little further, went to the employee Java model. I was able to identify that there was a schema name change, there was a sequence change that changed as well. So I was able to make those modifications for us, which is great. It's going to update the database configuration as well. Looking at our to-do list, you can see that we now have three, we're on the fourth of the to-dos. So it's able to chug along here. So I made all the changes to the code. Now it's actually going to do a build and validate that now that it made the changes to the Java code, can it actually still build and validate that. So now it's doing the build project. So it's doing that right now. And there we go. It's like it built. Excellent. The build succeeded. Now it's going to generate some unit tests. So it's actually going to go through and, based upon the code and the context, generate a handful of unit tests and actually build a little report that will tell us the results of those unit tests. So that's going to run right now. And then when this finishes, the final step is to show a report that will show the results of the conversion. So those are generating right now. It takes about a few moments for that to run. This report will just keep getting added to as it runs and goes on. This is a live demo, so hopefully everything will go smoothly. Sometimes it decides to not run every test or have a couple errors, but often it is able then to generate them pretty smoothly. So this is take another few moments before it's able to generate the final report. All right, so it had one failure, but that's not too uncommon. So it's able then to build, test, and then delete the ones that don't work, and then there it goes. So it's able to, it basically is able to generate a number of tests. If some of them fail, it deletes them. But you can see it still had 28 tests created, and those 28 did pass. So we actually, of those, we had 100% success rate. It was able then to actually show us the tests that were actually ran, inside of those classes, and then the time it took for those to actually run, you can see here. So that's now complete, and we have that validation. So now that that's finished, it's going to move on to the next step, which is building a final migration report that will kind of show what all the files that were changed, modified, what actually happened, so that way we can see the results of this code conversion. And that'll just take another few moments for that to get generated. And while this is running, we can do a quick review and see what actually all changed. So we have the POM to XML was modified for our dependencies, our database configuration, so we can actually concretely talk to the Postgres database with the correct configuration. The employee model was modified in order to match up to the database table that represents. The employee service as well, which called into two of those procedures. So actually, if I click into this, I don't think I talked about this at much detail while this runs. You'll see we actually had a prepare call, and this was calling into our what was our Oracle package, the HR package.assignManager, so it knew to change the signature to change it to the appropriate schema name. And the signature in this case didn't change, but it was able to change the casing and change the prefix on there. So that way, those function calls would actually work. So that's now finished, and then here's the final report. So 7 files were updated, shows what actually happened. Here's the directory structure before and after. So you can see that we had these files before, what was changed on the post side. And some things didn't need to change, some things did change, and it has a few more details on all those aspects. So that's the demo that I wanted to walk through. So I'm going to switch back to slides now to kind of wrap up. So in summary, on the benefits that we walked through today is that we looked at both schema and client code conversion. We talked about the powerful agentic self-correction aspect that happens during the schema conversion. And then we also talked about the integration with other extensions like the app mod extension that we're so proud of. Lastly, we have this slide here that actually has a QR code. So if you want to get access to this tooling and to the extension, it's currently on the marketplace and available to grab. So with that, I'm going to hand it to Luigi, who's going to talk about the next step of the journey, which is performance tuning. Thank you.
Thank you, Jonathon. Thank you, everybody, for coming to this session. Sorry, getting this. OK, good. I'm Luigi Nardi, CEO of dbtune, and today I'll talk to you about achieving high performance. So the idea here is that now you're migrated from Oracle to Postgres. And the next natural question is, how do you provide the high performance that your users demand on this newly deployed instance? So when I think about performance, the first thing that comes to mind is a race car. But of course, it's not just about the car itself. It's about the team, and it's about the tools that they use to squeeze every single millisecond to get a podium. And in the past, things were manual and labor-intensive, and today things move at the blink of an eye. It's really impressive to see how quickly they change those wheels. Now, if you imagine Postgres as a car, it's only with the right team and the right tools that you can achieve the best performance. So let's talk about that today, and I will show you how you can get your Postgres to win. Performance tuning is a continuous effort. It's not a one-and-done activity, unfortunately. And just as in the Apollo example that we just saw on the migration from Oracle to Postgres, there are many other specific moments in time when you need to tune your instance. We're talking about migrations from on-prem to the cloud, for example, or Postgres version migrations. And then there are other specific moments in time, like, for example, downtimes, which are often caused by the fact that the instance is getting performance degradation. And in that case, you are in a fire alarm mode. In addition to this, there are moments where you should think about tuning as a regular basis. For example, when you scale your instances up or down, which happens quite regularly in the cloud era. And when your application workload changes, which basically means you're developing your application, you're adding features, and your workload is changing, right? And that's also a very regular activity. And then other moments in time where the distribution of your tables is changing, and this affects the query planner. And when the query planner decides for a different query plan, then often another round of tuning would really benefit your performance. The issue here is that the complexity of databases is really increasing exponentially over time. And every workload and machine is unique. And the way the server is configured really affects the performance of your application. So we are at the moment in time where the complexity is measured in tens and hundreds of server parameters. And in the past, the manual tuning maybe could be enough, but today we are really out of what a human can and all tools can really do. And so how do we do this effectively? And Postgres really has the ability to deal with enterprise workloads and deliver top performance across the board. You just need the state-of-the-art tools to deal with this complexity, and this is really where dbTune comes in. dbTune is an AI agent that learns by observation, adapts to changing workloads, and automatically tunes your Postgres instance with minimal supervision. Let's get into details. We have teamed up with Microsoft to give you the state-of-the-art performance tuning and to make every team to deliver high performance on their applications. dbTune is based on Postgres-specific models that learn. They learn how to deal with your specific workload and provide a workload-aware optimization. And this is really key, workload-aware optimization. You can set it up in minutes. You don't need to be an expert in AI or performance tuning to operate dbTune. And it's highly scalable, meaning that now if you have tens or hundreds of instances, you can literally tune them in parallel. And it doesn't matter how complex each node is. So we're changing the mindset from a reactive approach where you tune in a fire alarm mode when you really have an issue in your production system to proactive approach, where you basically set up a tuning perhaps every week or every other week, depending on your needs. Our analysis shows that dbTune can significantly optimize your infrastructure cost and drive large improvements in application and your team's productivity. So it gives you up to 10x improvement in performance in terms of latency and throughput. And what's really interesting about this is that the optimal configuration, it's provided by dbTune in a matter of just a few hours, usually 3 hours. And if you compare this with manual tuning, which usually takes days, this is literally an order of magnitude difference in terms of productivity for your team. But most importantly, dbTune can also help you optimize your Postgres fleet and avoid over-provisioning, which, as you all know, over-provisioning is really, really present in every single deployments that we see out there in the industry. dbTune can help you with right-sizing your instance and consolidating your databases. It's completely automatic. and it's fully built into Flexible Server. With dbTune, you worry less about the infrastructure, and you can use it periodically, as I was mentioning before, as a proactive approach to tuning. This really becomes a maintenance activity where you're basically doing performance tuning as a performance tuning maintenance activity, okay? I will give a quick demo. This is our platform, and you can SSO with your favorite Microsoft SSO. You add a database instance here, and you add the name of the database instance. You select Azure Flexible Server, and you click on Add Database. dbTune shows you the historical queries, and it provides also a recommendation on what are the queries that you should tune. If you're not happy, you can always tweak this, but in most of the cases, this is just enough. And then you press on the Start Tuning button. And here you go. It just starts tuning automatically. So here you see some performance metrics. You as a database engineer, DBA, or developer, you can observe. But most importantly, it also gives you all the changes that it's making on the system. So here in blue, we have the initial configuration of the server, and you see all the parameters. And in green, you have the best configuration found by dbTune. And this is a really nice 2x improvement in performance on this specific instance here. So there you have it. dbTune can quickly and easily improve your performance of your databases. If this vision excites you, please go to my Microsoft Marketplace and check it out. This is all I have for today. Thank you very much for listening. And Guy, give it back to you.
Thank you. All right. Well, thank you. Honestly, I really love, Ashokkan, I really love that the end result of the migration was a better experience for your customers. That's a really good to follow that process. And Jonathon, honestly, I'm impressed that the migration works well enough that you can demo it live. That, very, very impressive. And I think, Luigi, the fact that now there are performance tuning tools for Postgres available on the marketplace, I think it's a really good shift to that point where you've got those kind of choices to save on performance tuning efforts. So I'll just quickly go through some next steps. There are some related sessions that you can go look up. Some of them have taken place, and there's also a lab, so you can go look at the recordings. Lab is running 4 times. I think there's another one tomorrow. Really, really valuable lab on building AI agents with Postgres. We're around all the time at the expert meetup area. Like I say, we'll hang around here for as long as you like. And we'll also be hanging around at the expert meetup area in the hub as well. Couple of other things. Azure Accelerate. This is a way to get access to experts to refactor, migrate, modernize. Excuse the animation. So this is a good one to go check out. And if you missed the QR code and want to check it out, I can go back and we can share that. And we would love feedback as well. If this was useful, if there's things you'd like to see different, it'd be great to hear your experience and to give us feedback. So with that, I think we've got maybe 2 minutes, 3 minutes for questions. If anyone has any questions right now on anything they've seen today. All right. Well, we'll be. Sorry. Yeah. Go ahead.
Yes. So the question was. Converting things like Oracle packages, that kind of PL SQL, that level of complexity? Yes, it does. In fact, during the demo, I may have went through it kind of quickly, but there was that HR package. That was actually an Oracle package that had 2 procedures in an Oracle spec and Oracle body, and that was able to be converted by the multi-agent orchestration. Yeah.
Any other questions? Yeah, go ahead. Are we planning anything similar for MS-SQL? I'll repeat it.
We are not currently, no, not currently on the roadmap right now. Yeah.
Great question, though.
Yeah.
Any other questions? Well, we'll be hanging around. So with that, thank you very much for coming to the session. Appreciate your interest.